Okay, so welcome to our second training video for Tethys. Last time we talked about GeoServer and web mapping a lot. This time we're going to cover a whole slew of things. We're going to talk about file management, and in that process we have to talk about CKAN. We need to talk about creating workspaces in your app so that you can manipulate files in your app. We also need to talk about how you customize your app for different users, and we'll do some more kind of advanced form and user input topics. And our objective with the app we're going to develop today is going to be to play around with some of the rapid output or repeat output, depending on who you talk to, for the ECMWF workflow. So part of what we're going to do today is I'm going to show you how to use the Netcdf Python library to parse that data and play with it a little bit. I am not the expert on parsing the rapid output. That is definitely Alan. But he showed me a few things. Hopefully I can communicate those to you as well. So let's go ahead and get started. What you're seeing here is my Ubuntu development virtual machine. I have a terminal pulled open. I've also got Chrome and Sublime waiting for our use today. As always with Tethys, the first thing you've got to do is activate the virtual environment. Okay, and you can do that using this path with the dot, or you can always use the .t if you have that shortcut installed. If not, it doesn't come installed by default if you install from scratch from the installation instructions. But if you're using one of the images from Numpy, you should have that shortcut. Okay, so the first thing that we'll have to do is we need to install several dependencies on our operating system in order to work with the Netcdf files. So I'm going to use the apt-get package manager. Install. And what we're going to need, we need to make sure, we should already have this, but we need the development files for Python. We need this library and this one. Okay, we need the Netcdf library. Okay, so we need all of those. Now, it takes some time to install those, so I have already installed them. So you can see it says these are already the newest version. But when you're going through this on your own, you will have to install those. Also, we need to install the Netcdf and Numpy libraries. I guess we don't really need Numpy, but it's useful to have. So you do that using the the pip Python package installer. And again, I've already installed these. It takes just a little bit of time. I didn't want to do that for the tutorial today. Okay. Go ahead and clean that up. So after we have our packages installed, now we can go ahead and start Tethys. Tethys manage start. Okay, and then in Chrome, I'll go ahead and navigate to it. It's running on localhost on port 8000. And I'll log in. If you're using the Numpy image that we gave you, the username is Tethys, and the password is pass, P-A-S-S. And I don't want to remember this. Okay, so you can see here's the GeoServer app we made last time. I also have the first app that we made during the boot camp. What we need to do is we need to link our Tethys with a CKAN server so that we can use it. For Numpy, we have a CKAN server at numpy-ckan.cloudopt.net. Okay. And I'll just give you a brief overview of CKAN right now. CKAN is kind of a file dataset sharing program. It's a website that is free and open source, so you can install it on your own server and kind of create a dataset sharing platform. Let's go ahead and look at the Datasets tab. So the way that CKAN works is files are stored as resources, and those resources can be grouped in datasets. So what we're looking at is we've got 165 datasets. Most of these are the forecasts that are being generated from some of the things that you set up in Alan's app. Okay, they're being deposited in CKAN. So let's look at Gonzalo. Okay, so you can see Gonzalo's app is running here, and each one of these data sets represents a different forecast period. For ECMWF, they come in twice a day, so that's why you see the time is either midnight or noon. Okay, twice for each day. Okay, and when you access the app, let me just bring it up. Or whoops, Tethys.cloudapp.net. Okay. Oh, I don't remember. I think I've got. Oh, good. Okay. So when we go into the Streamflow Prediction App, do you recall we set up watersheds during the boot camp? We go into Gonzalo's. Here we can view it. Okay, looks like he got one in Texas. It's great. So when I click on one of these reaches, what it does is it goes and downloads the data from CKAN, and then it parses the Netcdf file that's in that data set. Actually, there are quite a few of them, and it generates the plot here. In theory, anyway. So let me show you, while we're waiting for that to load, if we drill down into one of these data sets, so we'll say maybe this one was today at midnight, or yeah, we look at this one. No. Oh, that's right, Gonzalo's is not configured properly. Sorry, Gonzalo. Let's look at one I know works. So his is only pulling in one of the forecasts for some reason. If we look at Tim and Allie's, we click on one of these, you can see there are actually 52 different resources in this data set. Each one of these represents one of the forecast members of the ensemble forecast. Okay, and there are 52 of them. So the reason this isn't working is because we never resolved that issue with Gonzalo's data.
Yeah, I'm using that, so probably I should delete it.
So, well, yeah, it doesn't make a big, there's not a big deal. So, anyway, so what we're going to do is we're going to open up into, or connect to CKAN. We're going to look at these data sets, eventually download the resources, which are zipped up Netcdf files, and then we're going to play around with the Netcdf files. Okay, so that's where we're headed. So back to Tethys, we need to link it to CKAN to start with. So we go to the site admin. In the Tethys services pane, there's a dataset services link. You remember when we talked about GeoServer, we used the spatial dataset services link. It's a very similar process. So in here during the boot camp, we already set up a link to, in fact, this same CKAN server. We're going to go ahead and create a new one just to illustrate the process. I'm going to call it Nephi. Okay, and the way that we link to this is we take the URL here, I guess the host of our CKAN server, we paste it in there, and then we need to give it, like it's suggesting down there, the endpoint of the API. So I'm going to type API, the version, which currently their version is 3, and that's the version supported by Tethys, version 3. And then we add action to the end of it. Okay? Now, we don't necessarily need an API key, but if we want to be able to publish data sets, then we will need an API key. The way you get an API key is you sign up for an account on CKAN and you log in. And if you click on your little user icon in the top, it'll bring you to your user profile. Okay, and you will see the API key down here on the left. I'll just copy that. Okay, and your capabilities in CKAN will depend largely on the permissions provided by this API key. I happen to be an admin user right now, so I can probably do everything. So I'll go ahead and save that. Maybe if you're following along, there's the full API key. You can go ahead and use that one. Okay, so now we've got this new dataset service that is linked to our CKAN. It's called Nephi. And I'll show you how to work with that in the code. Okay, so the first thing that we need to do, though, is we need to create a new app for our playing around today. So I'll go back to the terminal. I'll go ahead and hit Control-C to stop the server. Let's clear that out. And then what I'm going to do is use the scaffold command. So I'm going to change into the directory where we've been putting these apps, which is the home directory, Tethys dev. Go ahead and list those. Right now we have 2 apps in there. Let's make another one. So we do this using the scaffold, and I'm going to call it CKAN app. Okay, and I'll just accept the defaults for all these different options. Clean up the screen. And if we list the contents now, you can see we've got a new app in there, Tethys CKAN app. Now we need to install it, so let's go into that directory. And we run Python setup.py develop, because we're going to be developing the app. Okay, so it installs the app. Now we can start our server again. Tethys manage start. Okay, and let's go to apps. And there's our app, CKAN app. All right, and it's a nice aqua green color. Now I'll just quickly note that I'm doing this pretty quickly. I don't expect people to be following along live right now. I want to be able to cover a lot of content. I am recording this, and the video will be made available. Forgot to mention that earlier. Still working on the GeoServer one, by the way. Okay, so I'm going to go ahead and go to Sublime, and I'm going to open that folder where we created our new app. It's in my home directory, Tethys dev, CKAN app. I'll just open that. Now I can see the project in my tree here. I'll expand those. Okay, so the first thing we're going to do is go into our controllers, and we're going to play with the controller for our home page. And just like with GeoServer, there is a method we import from the SDK called getDatasetEngine. And we can use this to retrieve an engine object that allows us to connect to our CKAN server. All right, I just noticed that there are some questions in the chat box. I apologize. First question is, what is the difference between GeoServer and CKAN? So CKAN is for generic file storage, and all it does is store files, a lot like Google Drive or Dropbox. Whereas GeoServer is specialized for spatial data set types. So if you, for example, want to serve shape files and show them on a map, GeoServer would be able to help you do that, whereas CKAN could store the shape file but would do nothing to help you display it on a map. Okay, so GeoServer is really for spatial data sets. CKAN is for your other data sets, like this Netcdf file we have, or other model files, text files. Okay, and there is a way to make data sets private. When you create new data sets, there's a little option on the form that allows you to make them private. Okay, and you can, I believe, do that using the Dataset Storage API as well. Okay, and on that note, before we get too far along, let me show you where all this is in the documentation. So docs.tethys.ciwater.org. So if we go to the Software Development Kit, and what we're going to be working with is this Dataset Services API today. Okay, and you can see it talks about the key concepts that we talked about. There's links to CKAN documentation. It's documented how to set up a new CKAN server with your Tethys and how to get started. There's lots of great documentation here. Okay, so back to controllers.py. I just imported this get dataset engine. I'm going to go ahead and create a CKAN engine. And what the CKAN engine is it's an object that has methods on it that we can call to interact with our CKAN server. Okay, so I just give it the name of the configuration I want to use. In this case, I want to use our Nephi CKAN server that we configured. Okay. In the documentation, you can see this heading Dataset Service Engines reference, and there's a link for the CKAN Dataset Engine reference. And this just lists all of the different methods that we can call on this engine object that we just created, including kind of creating resources and data sets, deleting them, retrieving them. We can get a list of them. We can search them and update them. Okay. So those are kind of the things that we can do. So now that I have this engine, what I want to do first is just list the different data sets that are in CKAN. List data sets. Okay. And just like GeoServer, there's an option to print it to the console. In GeoServer, it's called debug. And this one is called console. I apologize for the difference. They do the same thing. So console true will kind of print some debug information to our terminal. So let's go ahead and see what that prints out. I'll go back to our home page in our app, refresh the page, and you can see what we got back was this dictionary, and it has several keys in here. One of them is called result, and you can see that result is a list of names. So these are all the data sets in that CKAN. Okay, and it also has this parameter success, and it's true if it was successfully able to perform that operation. So I'll go ahead now, and what we want to do is I want to assemble only the data sets that are kind of the rapid, ECMWF rapid workflow data sets. So I'll create a list first, an empty list for us to put those in. I'm going to check if the response, basically that operation, was successful. Like that. So if it's true, then I'm going to loop through these data set names that is in the response result. Remember, that was a list of names. And the way that we can tell, if we look at these, the data sets that are associated with Alan's app are all prepended with this ERFP. Okay, and you can see most of them are those data sets. Looks like we've also got a WARF data set in there too. So we want to just pull the ERFP ones. So the way I'm going to figure that out is I'm just going to use the conditional statement. If ERFP, that string, is in the data set name, then we'll go ahead and append that data set name to our list. Oops. It should be names, dataset names, append the dataset name that we're on. Okay. The next thing that we want to do, let's look at this list again. You can see that we have all of these. For example, this Curtis South, Alabama watershed has a whole lot of data sets, and the difference between them is this timestamp. What I'd like to do is get a list of unique data sets, or I guess unique watersheds. So what we need to do is chop off the timestamp and the ERFP, and then just get a list of these unique names. Okay, and you'll see where I'm going with this in a little bit. So again, I will create a list. Okay, I'm now going to loop for ERFP dataset name in, loop through this list that is only the ERFP datasets. And I'm going to go ahead and split that, the name, and I'm going to split it on the dashes. Okay, so let's look at what that would do. You can see here's a dash, here's a dash, here's a dash. Okay, so what that's going to do is split this string into a list with 4 elements. The first one will be ERFP, the next one will be the watershed, the next one will be the subbasin, and the last one will be the timestamp. Okay, so let's go ahead and get just the parts minus the time, so no time. Okay, we're going to have that be, we're going to join them again by dashes. Okay, and remember we're going to use a Python construct called slices. We're going to take everything from the beginning to the third element, which is really the 4th element because it's 0-based. Okay, and we'll join all of those together by dashes again. So essentially, we get the same thing without the timestamp. Okay, so now what we want to do is assemble a list of these where the names are not repeated. So the way we do that is we're going to say if this no time is not already in the unique watersheds list, then we'll go ahead and append it. Okay, so the first time it won't be in there, it will append it. Every time after that, it will be in there, so it'll just skip it. Let's go ahead and print this so we can see what we've got. This unique watersheds list. Let me go ahead and turn off the printing of the console of that operation. So we'll go to the page, refresh it. Okay. And if we scroll down here, it's hard to see. We've got a list right here that printed out, and you can see they're all unique. Okay. Let's make that easier to see and put it on a web page, huh? So let's go ahead and pass that unique watersheds now to the context, so it will be available in our template. We'll open up the home.html template. And what I'm going to do is I'm going to get rid of this app actions block. I'm going to clear out this. We'll add a header to this page that is the Nephi watersheds. Okay, and we're going to create an unordered list. That's what the UL is. I'm going to change my tab size to 2. Okay. And we'll use a for loop this time inside of our template. So for watershed in unique watersheds. Okay. We're just going to print out a list item for each watershed. Recall the double curly brace syntax prints the contents of the variable to the template. Close our for loop and close the unordered list tag. Okay, let me go ahead and refresh the page. So now you can see we have a list of unique watersheds, essentially, that are our Nephi watersheds we set up during the boot camp. Okay, so the next thing that we're going to do is go back to our controllers.py and we're going to modify this a little bit. The list is great, but what I want to be able to do is select a watershed. So we're going to add a select input to the mix. So we'll go back to controllers.py, get rid of this print statement so we're not jumbling up our output on the terminal. So I'm going to create a list for the options for our list, or for our select box. And then we're going to go ahead and loop through all of these unique watersheds. Okay. And this time, what we'd like to do is for our select input, we'd like it to have kind of a pretty name. We don't want it to be this kind of ugly name. Instead, what I'd like to see is maybe the middle snake voicey showing up nicely without underscores or dashes in there. So we're going to do some string operations on the watershed name. Let's go ahead and split it into parts again. Again, on the dashes. This might seem kind of repetitive, and it is. There's probably a better way to do that, but this is just for the demonstration mainly. So I apologize if you're a big programmer and you're kind of cringing. So let's go ahead and split it. If you recall, now we'll have kind of 3 parts. The second one will be just the watershed part. Okay. And I'm going to call this pretty watershed, sorry, not watershed, sub-basin name. That's the third element. Remember, it's a zero-based thing. Let's go ahead and print those so you can see what I'm talking about. Pretty watershed name, pretty sub-basin name. Okay. Refresh the page. So you can see it printed out middle snake, Boise Basin. Okay, so we've now got kind of this name split up. We still have underscores in there though. So let's go back and get rid of those. So I'll do a new operation, string operation called replace. What we're going to do is replace those underscores with spaces. Okay, and then I'm also going to change the case to title case so that it capitalizes the first letter. And I'll do that on both of them. If we refresh our page, look at the console, you can now see they're kind of a lot prettier. Okay. For the select input, we want to show both of those kind of listed together as the option. So I'm going to go ahead and combine them. Pretty watershed name. Concatenate it with a string that has a comma and a space. And then concatenate that with pretty subbasin name. So that's our combined. Okay. I'm going to get rid of this print statement now. So what we're going to do, we have that list that is going to take the watershed options. Keep doing these singular, they need to be plural. Watershed options, we're going to now append. Remember, the select box takes a tuple. So the first is kind of what will show up as the option the user will select. So we want that to be combined. The second one is the value that will be passed when they submit the form. This is the more computer-friendly one. So we'll just give it the watershed option that has all the dashes and underscores in it still. Okay. So now we've assembled our options. Let's go ahead and create our select input. I guess before I do that, I need to import the Gizmos library. So back up at the top here, I'll import Tethys apps.sdk.gizmos, and the star means I'm just going to import everything. So go ahead and import our select input. The display text of the input will have, say, watershed. Okay, the name that it will be submitted with is also watershed, but lowercase. We don't want multiple options available. Got to find a way to use the multiple because it's cool. And for the options, we give it this watershed options that we just created. Okay. Then we need to pass this to the context. So select options. Select options. So now it's available on our template. The last thing we need to do is we need to go and replace the content in our home page. So I'm going to get rid of this list now. And instead, I'm going to create a form that has our select input in it. Action is nothing, meaning it will submit to the same page. Method, I'm going to use the post method. Okay. Close the form tag. As always, we have to put our CSRF token in there. To use the Gizmos, we need to load the Tethys Gizmos library here. Now I can insert the gizmo, which is called select input. And we give it the options that define it. All right, last thing we need is a submit button. Name equals submit, type equals submit. I'm going to use some bootstrap styling we talked about in the last tutorial, just to make it a nice looking button. Okay. So there's our form. Let's go refresh the page. All right, so we've got now select input. You can see the names of the watersheds are pretty, uppercase and spaces. and I can select them. Now, it doesn't do anything when I hit submit. So let's go handle that logic. Okay, and in the process, what we're going to do is, if you recall, all these data sets have times associated with them. So what I'd like the user to do is select first a watershed and then see a list of the timestamps that are available, and then select timestamp for that watershed. Okay, so to do that, we've got to do kind of this multi-stage form. So we're going to do that right now. So let's modify first, since we're on the template already, let's modify our form. What we're going to do, so we're going to create in a conditional statement, we're going to have a variable that will tell us whether to show the time input or not. Okay, and we'll create that in the controller when we get back there. It'll be called show time, but not the TV station. Okay, so let's go ahead and do Gizmo. This will also be a select input, and we'll call the variable that will define it time select options. Okay. So let's go to our controllers. We need to define this time select options and also this show time variable. So in the controller, let's go ahead and handle the logic for when they submit the first time with the watershed selected. So if request.post, this is kind of the pattern, and we want to know if the watershed input has been submitted with that form. Okay, so if that watershed has been submitted, then let's go ahead and extract the watershed. That they selected. Get that from our post variables. Okay. Remember, this watershed name is coming from the name that we gave the select input. So that will be the value that they submit, that they select there. We also, when this is submitted, we want to define the show time variable, set it equal to true. So now they've selected a watershed, we want to show the time options. We need to define a default value as well for show time. That we'll do that outside of the conditional. So by default, it will be false. If they submit the form, then it will be set to true. Okay, and let's be sure that we pass that to our template. Show time. Show time. It's funny hearing it, speaking it, because it was in my head. I never made the connection that it was like show time. But now hearing it, it's kind of funny. Oh well. Okay, so now what we want to do is assemble our list of options for the time selector. So time options, let's create an empty list that we can put those in. Okay, what we're going to do is say for dataset name in ERFP dataset names. Remember, that's our kind of list of dataset names that's not unique. It has all of the timestamps in it. And what we're going to do is we are only interested in the ones that are associate with our selected watershed. So we're going to say if the selected watershed name is in that dataset name. And why don't we go ahead and print right now that result. Dataset name. Okay, when I refresh the page, it's going to throw an error because we haven't defined the options for our text select or maybe not. Okay, I bet when I submit this. So I'm going to select this one. It's the one I made. Here's our error because we didn't define our time options, but we can go to the console and you can see that it printed out only the watersheds that correspond with that select option that I selected. And now what we need to do is grab this time off of these, okay, and assemble a list of just these times. So let's go back and do that. So we're going to take this data set name. Instead of printing it, I'm going to split it into parts again, hopefully picking up on this pattern now. Split again on the dashes. Okay. And what we can do is we know that the time is going to be the last element. So a shortcut for getting the last element in a list is just to use the -1 index. Okay. Now what I want to do is break that up into just the year, the month, the day, and the time, so that we can make it pretty for our users. It's all about making it pretty. So year equals time, which is beginning to the 4th element. And you'll just have to take my word on these. Time is going to be from the 4th element to the 6th one. Day equals time from the 6th one to the 8th one. Hour, 9th one to the 11th one. Okay, we skipped one because there's that little T in there. See that T? We don't want the T, we just want the hour. Okay, and now what we're going to do is we're going to concatenate all those into a pretty time. We're going to use a little different method than I've shown before. Okay, I'm going to define this string that has basically placeholders that we can fill in. Wow, if I can type. So we want maybe month, day, year, because that's a way that's common. Okay. There are other ways we could do this, but this is the way we're going to do today to illustrate this. Okay, so we have these different placeholders, and what we do is on that string we call this format method, and then we just pass the arguments in the order that we want them placed. So for the 0 position, I want the month. For the 1 position, I want the day, and so on. Year, hour. Okay, and it will create that string for us with that nice format. Okay, remember the whole point of this is to assemble a list for our options for our time select. So let's append that now that we've got a pretty time. Again, we give it a tuple, give it the pretty time for what will be displayed to the user. For the value, I want the ugly full data set name. Okay, because we're going to use that to look up the data set from CKAN. Great. Last thing we need to do now is just define our time select options. Okay, and we do that just like we did before. Select input, display text equals time. Okay, name equals time lowercase. That's what we'll use to look it up. And options, we're going to give it these time options that we just defined. All right, and then let's be sure that we pass that to our context. Time select options. Time select options. Okay. And our template is already wired up to take that time select option. So let's go back to our page, which is in error right now. Oh, looks like I've got a syntax error in my controller. So let's look at line 71, which is here. Oh, I put a comma there instead of a colon. Okay. All right, so the way that this form works now is I can select the watershed. Maybe I'll select Tim Alley, submit that, and now the time select shows up with all the times for that watershed. And you can see it's kind of formatted in a human-readable way. So what I'd like to do is be able to select the time and hit submit. We have a problem though. The user can still change this, and it doesn't correspond right now. It went back to the default value. Remember, I selected this Tim Alley one. So it's kind of not ideal for the user. So let's add a little bit of logic to make that a little more user-friendly, foolproof. So we'll go back to our controller. What we're going to do is just say, create this new variable called selected watershed. I guess this is what we're going to do. We're going to come up here. Remember, we have this selected watershed variable. I'm going to pull it outside of that conditional so we can give it a default value and set it to the empty string by default. Okay. So now it will be defined always, not just in our if statement. And then I'm going to pass it to our context so that it's available on the template. And on the template, I'm going to wrap this first select input with a conditional. I'm going to say if selected watershed, basically if that is anything but the empty string, then we'll do something else. If it is the empty string, which is the default, show the select box. So basically, if they haven't selected anything, we'll show the select option. If they've selected something, then instead of showing the select box, what we're going to show is bold watershed, just the text basically. Okay. So let's go take a look at what effect that had. So I select this one, I submit it. Now you can see the text is displayed here and of the watershed that I selected, and then we can select the time. Now I didn't do the pretty formatting on this. The next step would be to go back and pretty format that so it kind of matches what they selected. This is just the value that was submitted with that. I'm not going to do that right now though, so that we can show some other more interesting stuff. Okay. So now what we need to do is when we submit this, we select a time. Let's go back to our CKAN. That would be equivalent of selecting one of these data sets. We want to list all of the different forecasts that are in there on a new page. So let's go create a new page so that we can do that. So in my templates, right-click, new file. I'm going to call it forecast. Oops. .html. Save that. Okay. Speed things up a little bit. I'm going to do some copying and pasting. Basically just going to extend the base template. Right now it has nothing interesting in it, just a header. Okay. Then we're going to go to our controllers and define a new controller for this page. Okay, remember this is just a function that accepts this request object. Something that I haven't done that I should make sure I do is indent using spaces. Okay, so an empty controller there. And then the last thing we have to do is go into our app.py, and we need to add a new URL map. Okay. And again, I copied and pasted this. Now this URL map, though, is kind of special. So I named it forecasts. I'm using a variable here. The variable will be the watershed data set that they selected, okay? And I'll show you exactly how we use this. So what we need to do now actually is go back to our controller and allow it to accept this variable. Notice I also pointed it at this forecast controller. So let's go back to controllers, and I'll create a spot for that variable to be passed to the controller. Okay. And let's do some interesting stuff with this. We'd like to maybe at the top of our page show a pretty version of the watershed name. This is actually nearly identical to what we did on the previous page. We split it. This is going to have the dashes and the underscores in it. And we kind of concatenate it into this pretty title. We'll also pull out the time like we did before. Okay. So at this point, you're seeing I'm starting to reuse a lot of code. If I was doing this for real, I would break that out into a separate function that would maybe take a watershed data set name that has the dashes and underscores and returns the pretty name, so that I don't have to be copying and pasting this code all the time. That would be better programming practice. But where this is just a demo, I'm doing it quick and dirty. Okay. I also pass this title variable and the pretty time to the template. Let's go modify our template so that it actually uses this. Underneath the main title, which is forecast, I'm going to put these subtitles. Basically display the watershed and the time that the forecast was issued at. Okay. To test this, I need to use one of the dataset names. I'm going to use this one, /forecasts is the pattern. Okay, if we, as a reminder, if we look at our URL pattern, it's going to be CKAN app / some watershed dataset /forecasts. So that's what I have here, CKAN app, watershed dataset, forecasts. You can see it parses that URL variable into the nice pretty text and pretty time. Okay, so the next step, what this page is going to have is just a list of all of those data sets that are in there. So let's go back to our controllers. And what we want to do, oh, wait. So before we do that, actually, we need to make it so that we can get to this page from our previous page. So after they select a watershed and a time, we want it to bring us to that next page. So we actually need to go back to our home controller to do that, to pass it off to the new one. Okay, and I'll just put it right here above the context. So if request.post, remember this, they're going to submit a form, and this time if it has the time option in it, that means they've selected a time. We'll pull out selected data set. The request.post, the time that they selected. And recall the value of that is the full data set name with the timestamp. And then what we're going to do is we're actually going to return. Okay, remember at the bottom of this function we return to render the page. We're going to kind of short circuit it, and instead we're going to redirect it. Okay. And in fact, to use the redirect function, we have to import it. from the Django shortcuts. Okay, so back down to where we're returning it, we're going to redirect it. We're going to send it to the CKAN app forecast controller. And remember, that one accepts an argument, has a URL variable that is the watershed dataset name. Selected dataset. Okay, so that's how we can redirect to a URL that has variables in it. So it will construct that URL for us and redirect the page. So let's test it out. I'll refresh this. I'll select a watershed, submit it, select a time, submit it, and now we got brought to our forecast page. The redirect function constructed this URL for us. And this is the watershed that they selected. Okay. Okay, so now we can handle the logic of this page, the forecast page, now that we can get there. So we're going to need a CKAN engine again. And what we're going to do this time, go ahead and paste this in, is we're going to use this get dataset method on the CKAN engine, and we can just give it the watershed dataset that we're passing in through our URL as the ID. Okay. I'm going to do something goofy on this page. I'm going to list each one of these as a button. So we're going to create a list of buttons where each button will represent one of the forecasts. So what we want to do first is check to see if this operation was successful. If it was, we'll go ahead and grab the data set out of the result. The data set's going to have a whole bunch of options. So why don't we, for illustration purposes, go ahead and pass that to the template so that we can see what's in it. So on the template, I'll just print out this data set variable. You can see it's a dictionary, and it's very large. So it's got a whole bunch of keys in here. We'll do like a control find on here. One of those keys is going to be the name. Okay, and you can see that's the name of the data set. Well, actually, that's the name of one of the resources in here. So you can see there's a whole bunch of instances of those. The name of the data set is probably down here somewhere. I'm not going to take the time to find it. One of these is resources. Okay, and what that is a list of more dictionaries. Each one represents one of these resources in here. What's contained in those dictionaries are all of these attributes and more. Okay, so it's kind of the programmatic side of CKAN. Okay, this is ugly. I don't want to look at it anymore. So let's get rid of that off our template. And let's go and create something more pretty to show. Okay, we don't need to pass this to our template. So what we're going to do is loop through the resources. Those are going to be our different forecasts. So for resource in dataset, remember it had that key, resources. Okay, and what we're going to do is create a button for each one of these resources. The display text of the button will just be the name of the resource, which is accessible at the name key. Remember we highlighted those. And then for now, the action of the button, or the href, we'll just say the resource, resource URL. Okay, and then we'll append that button to our buttons list. Okay, the URL that I'm talking about is every resource in CKAN has a URL associated with it. If I click on this URL here, it downloads the file for me. Okay, so that's what I put in the button, is that URL. Okay, we need to send the buttons to our template through the context. Okay, and then we need to go modify our forecast template. And all this is going to be is a loop through those buttons, and we'll create one of those button gizmos for them. To use the button gizmo, we need to load Tethys gizmos at the top of our template. Okay, gizmo is called button. The options are defined for each element in this buttons list. Let's go look at it. It looks a little ridiculous, but it's functional. So we have 52 different buttons on our page. Right now, they're wired up to the URL in CKAN. So if I click on one of them, it will download that file. So I don't know if that's useful or not. What we'd really like to do, though, is get into parsing these. So, and then eventually plotting them. So to do that, we're going to need a new page for our plots. And what I'd like to do is when I click on 44 here, I want it to bring up that new page and plot it, that forecast. So let's go ahead and I'm going to start backwards. I'm going to go into the app.py, create a new URL map. I'm going to name it plot, because I can't think of anything interesting to name it. URL that we're going to design is going to start with CKAN app. We're going to have a variable in here. This time it's going to be the resource ID, which is the ID of our resource. So when we select the resource from those buttons, we'll pass along the ID of that resource so that we can look it up really easily. Okay, and then plot. So that's the URL pattern. Sorry, my virtual machine wigged out a little bit. Okay, and then for the controller, again in CKAN, underscore app dot controllers. We'll call it plot. I keep doing that. Save the changes there. Okay. Let's go ahead and make that controller. What we're going to do, I'll just copy and paste it and talk about it. So it accepts, in addition to requests, the URL variable, resource ID. I went ahead and grabbed a CKAN engine with our Netcdf CKAN. I'm calling the get resource method on CKAN so that we can retrieve that resource. And again, I'm just using the resource ID that's passed in through the URL to retrieve that. Okay. I've also, I'm getting the resource back and passing it through the context. So I'm checking if it was successful. If it's not, then this will just be the empty string. Okay. So let's go create our new template. Call it plot.html. Okay. And in here, we'll do that scary thing where we print out the resource dictionary. Again, this one's not quite as bad as the dataset one, though. Okay, we don't have the buttons wired up yet, so to test this, I've got a pre-baked URL we can use. Okay, and what this is again our URL pattern, CKAN app / this is the resource ID of one of the resources, and the plot. And you can see, much like the dataset object, it is a dictionary. It's got a bunch of keys in it, including the name, ID, and other things like that. The URL is in here to download. Here's the URL to download the file. So we're going to be using a few of those attributes to get the file and work with it. Okay, but before we get too far, let's go ahead and kind of put some pretty titles on this page. So if we're able to get the resource, what I want to pull out of it, let me just paste this. Okay, just like we were doing before, only slightly different. We're going to get a nice pretty title, a time, and a forecast number. If you recall, if we look at these names, forecast number is here at the end. We've got the time and all the names, so we can derive all that information from the resource name. And that's what we've done here. Okay, we'll go ahead and update our context and just pass the pretty time, forecast number, and the title to the template. And then we'll go ahead and go into our plot template. And, oops, guess I didn't end up copying that. Go ahead and paste that there. So we're just going to print out the title and pretty time like we did before. Now we're going to also add the forecast number. This will just make it so that we know what we're looking at. Refresh this page. So we know we're looking at forecast 52 of that watershed in that time. All right. So now let's go ahead and wire up our forecast page so that when we click on these buttons, instead of downloading the file, we will get to the plot page. So we'll go back to our forecast controller this time, which is here. And what we're going to do is we're going to change our buttons a little bit. Okay? So in here, right now, we're linking to this URL. What would be better is if we just link to the plot page. Okay? So we're going to replace that href, plot URL, this plot URL variable. Okay. Sorry. And to do that, to get that URL, we're going to import a new Django function. It's called reverse. And it allows us to do a reverse lookup of the URLs in our website. Okay. So I'll define this plot URL to be reverse. We want it to be the plot page, and the plot page takes an argument, the resource ID. Okay, recall we're in this loop where we're looping through the resources so we can grab its ID out and pass that as an argument to the plot URL. Okay, pretty simple change. Now if we refresh this page, you can see down at the bottom of the page when I'm hovering over these that now they are linking to that plot page. So now we can go to the plot page. This is 40, 19. Very fun. Okay, now it's going to get fun. So what we want to do is we want to download the file. It is a zip archive, so we need to unzip it, and then we need to parse it into a structure that is compatible with the plot view in Tethys. To do this, I need these 3 Python libraries, OS, URLlib, tar file. Okay, OS will allow us to work with the directories and files on our system. URLlib will be used to download the file. Tar file will be used to unzip it. To parse the file, we need the Netcdf library. I'm going to alias it as NC, so I can refer to it as NC instead of Netcdf. That's mainly because I'm lazy. We're also going to need the date-time library to generate some timestamps. So I'm just going to get all the imports out of the way so we don't have to keep scrolling up and down. Okay, so back in our plot controller now, plot, down here below, the first thing that we need to do is if we're going to download the file, we need somewhere to put it. Okay, this is where we're going to talk about workspaces and things of that nature. So, and since we are on a website, we could have potentially many concurrent users of our website that are using it at the same time. So these workspaces really need to be individualized for each user so that they're not overwriting each other's files. Okay, so what we're going to do is get the current username, and that is passed as part of the information in the request. So you can get it from the request object that's passed here. There's an object called user, and it has an attribute called username. Not current user, username. Okay. The next thing we need to do is I don't want to hard code the path to my workspace. I want it to be relative to wherever my app is installed. And there's a little trick to doing that. So I can get the directory that my controllers, this script, we're in controllers.py. I can get the directory that this script is sitting in using this way. Okay, os.path.dirname. And there's this weird variable that's available on all Python modules or Python scripts called file. And that contains the path to the Python script. Okay, and this dir name will give us the directory of that file is in. So now we have the directory of this controllers file, which is the CKAN app directory. That's a great place to put our workspace. Okay, so now what I'm going to do is construct a path that will be a workspace for our user. So user workspace, os.path.join. Okay, I'm going to start with the controllers directory. I'm going to add a directory called Workspace. And then to make a directory inside of that that's unique for the user, I'm just going to use the current user's name. Okay. Now the reason that I am not just, controllers directory, if we were to look at it, is just a path. It's a string path with slashes in it. The reason I'm not just concatenating with slashes is to make it more generic. Python is cross-platform, and if you recall, in Windows, slashes and paths go one way, and in Unix and Linux, they go the other way. So this os.path.join takes care of making sure the slashes go the right way for us. So it's the safer way to construct your paths. Okay, and you'll see what it creates in a moment. So what I'm going to do now is I want to check to see if the workspace exists. When we first install our app, there is no workspace directory. So if it doesn't exist, we need to make it. So we're going to say if not, we're going to use a method in os.path called exists. And we're going to give it this user workspace path. So if that doesn't exist, then go ahead and make dirs. Make the directory user workspace. Okay. Let's go ahead and refresh our page and see what happens. So I'm going to refresh it. It'll run. If we go back to our Sublime, you can see now that I have this directory in here called Workspace sitting in my CKAN app directory. Okay. And inside of that is a directory of my username, which is currently Tethys. Okay. So we'll have this Workspace directory and a directory for each user in here that they can use for file manipulation. Okay. So the other thing we want to do to simplify things is we want to clear out any files that are in that workspace every time they refresh the page. Okay, so to do that, we do for file name in, we'll use this os.listDirs, which will list all the files in that directory. Okay, and we're just going to remove them. os.remove, and I have to do an os.path.join, give it the directory and the file name, because these file names are just the file names. They don't include the full path. So we have to construct the path for that. So that will just remove all of the files in, for instance, our Tethys directory. So it doesn't, one, get cluttered and take up lots of unnecessary space on our hard drive, and two, to make our job a little easier. Okay, so now we need to download the file. So I'm going to do file name. We have to give it a name, which seems kind of counterintuitive, but we need to tell it the URL to download and what to name it after it downloads it. So we're going to put it in the user workspace, and I'm just going to call it temp.gz because it's a gzipped file. And then I'm going to use URL lib as promised to URL retrieve. And the URL will be our resource URL from CKAN. And the file name is that temp.gz. Okay. So let's see if that works. Oh, I must have misspelled something. It is not listDirs, it is listdir. My bad. Try it again. All right. So we go into Workspace, and there it is. Here is our zip archive. It's binary, so this doesn't make a whole lot of sense. So now let's go ahead and unzip it. We're going to use the tar file method.open. Remember, the file is this file name. And when it's open, we'll just call it tar. And we'll do an extract all into the user workspace. Okay. Let's refresh the page. Downloaded and should have extracted. And sure enough, here's our Netcdf file. Okay, so we got the file. We created a workspace specific to user. So now we need to parse the file. The plot view for Tethys can't read Netcdf files on its own. I haven't made it like that yet. Maybe we can in the future. So for now, the burden's on developers to parse the file. Now the fun begins. Okay. So the first thing I'm going to do is I need to find the Netcdf file. Okay, which isn't as straightforward as you would think. We don't know what it's named because its name doesn't match the name of the file we download from CKAN. We renamed it anyways, called it TempGz, so we can't just guess the name. So what we need to do is just loop through the contents of this directory and find a file that has the extension .nc. Oops. So that's what this loop does. Again, we're using this lister and we're going to loop through the files. If we find one that has this NC extension in it, then we will basically grab that path. We'll assemble that path of that file and stash it. What break does is it will break the loop the first time it encounters this condition. Okay. There's only 2 files in there, but it's a little optimization. If we found the file we're looking for, we don't want to keep looping. So we just break the loop. Okay. So now we're going to use the Netcdf library, and we'll go ahead and open the file. We give it the path to the file, and we tell it to use the read mode. That's what the R stands for. So we can't write to the file, we can just read right now. Okay. Let's take a quick conceptual break, and I'll show you something about this file. So I've got pulled up here the Streamflow Prediction tool, and it's using these files that we're parsing in the background. Each file contains kind of the hydrograph, I guess you'd call it, the flow forecast for each reach on this map. It's very nice to look at it this way because we can just click on a reach, right, and select it. So the Netcdf file has many kind of time series hydrographs in it, one for each of these reaches. So if we go back to our code, what we need to do is just tell it a reach, and we do it by index. And right now, I'm just going to hard code it to take the first one, which is at index 0. Okay, so that's what that's all about. Next little bit, there's been a change in the format of these files, and it changed the order of some of the variables in there. So what we do is we just need to check, in order to get the data values out here, we need to perform a little check to check the order of these fields. So you can see this first statement checks to see if it's time, ID. Second one checks to see if it's ID, time, order. And based on that, we pull out the data a little differently. So we'll just take that one on faith. I'm not really an expert on that. Alan just told me I need to do it. So that will kind of save us some trouble there. The next thing we need to do is these files currently only have the flow values stored in them. So in order to get the timestamp for each flow value, we kind of need to construct our time series. Okay, we know the start date. So this is where we're going to use the Python date time library. We can create a date time object. And the start date, if you recall, when we did all our pretty printing and assembling the pretty time, we parsed out the year, month, day, and hour. Well, it turns out we're going to use that for a little more than just pretty text. So we initialize this date time object with the year, month, day, and hour. That will be our start date. And we know the timestamp is 6 hours. Okay. And what we're going to do is assemble our time series. So I'm going to make an empty list here. And we're going to increment steps basically. So I'm going to start on step 0. And we'll loop through all of the values in our data values object. So for data value in data values, And what we need to do is call this method to convert it to a list so we can work with it in Python. What we need to do is calculate the hour, or the number hours offset. That will be just the 6 hours times whatever our step is. So for the first value, it will be 0, so it will just be our start date. Second one, it will be 6. Third one, it will be 12, and so on, as we loop through this. So we'll need to increment that step. And we'll just increment it 1 every time we go through the loop. Okay, the time, the current time, will be basically our start date plus, and what we need to do is make a delta time object to add to this. And we can just tell it to be equal to the number of hours that we've calculated here. So our start date plus whatever offset. And then what we need to do is append that to a list. And it needs to be a list of lists. So append list, where the first value is the time, and the second one is the data value. Okay, not too bad. So we've constructed a time for each data value and put those into a time series list. Let's go ahead and close our Netcdf dataset. Okay. And for illustration purposes, let's print that time series. And a better way to do it would be for item in time series, because it's a list of lists. Print the item. Okay, let's refresh the page. No typos this time, that's good. And you can see, oops, we got to scroll down. Here's our list of lists. So the first element is one of these date time objects, and the second one is the value. This is the structure that Highcharts expects it to be in. It has to be one of these date time objects for the timestamp. Okay. So now, all we have to do is make our plot, right? Oops. So let me get rid of this print statement. We don't need that anymore. And what we'll do is we'll come out here and construct our plot. Now, something we need to do is, so it expects this time series variable. Right now, it's defined here inside of this if statement. If that if statement is not true, then that wouldn't get defined, and our page would throw an error. So I'm going to bring the definition of it outside of that, so at least we don't get a big ugly error. It won't work, but we won't get an error, and I'll get rid of it here. Okay, so we define the Highcharts time series. We're going to give it, the plot, a title. It's going to have or I guess a y-axis title, and the units is CMS. And then it's got this one series in it called Streamflow, and we give it that time series that we just constructed. Okay, we also need to define a plot view object that will take this plot object. Okay, we give it the time series plot object. We tell it to be 100% wide, fill the screen, widthwise, and 500 pixels tall. And then last thing, we need to pass that to our template. so that we can use it there. We'll go into now our plots.html. And what we need to do is load our gizmos. Okay. And just add our plot. Time series, so the options are defined in this time series plot. Okay. So let's go take a look at it. Okay, so this one isn't interesting. Everything is 0. So let's go find a different one. Go back. Another 0 one. Maybe what we need is a different watershed. So you notice it's kind of hard to get back here. Why don't we create a start over button in our navigation? So we'll go to our base template. We'll clear out the app navigation items. And I'll put in there a start over button. Okay, and all it's going to do is just take us back to our home page. CKAN app home. Start over. That'll make it a little more user-friendly. Okay, let's maybe select Tim Alley's. Go to the end. And look at one of these. There we go. Now we got a plot. Notice the values are extremely small. So it's still not very interesting. We're almost 0 on it, but at least it has some shape. Okay, so now we can kind of look at each one of these. Now, if we go back to Alan's app, what he's actually showing on here on this plot is the aggregation of all of those layers. So the mean, standard deviation, min, and max. So you don't have to look at all 52 on the same plot or browse them one at a time like we've done here. So that is kind of the big thing that I wanted to do. What we've done is we've dealt with CKAN, we've talked about workspaces, we've talked about plotting, parsing the Netcdf files. We've done a lot here today. So I've unmuted your mic. Does anyone have any questions about what we've covered in Tethys today? You're all still there, right? Or are you all asleep?
Still here.
Okay.
No else kind of a question. Can you go back to the code?
Yes, sir. You want the controllers?
Yes. Those two objects, the Highcharts, time series, and the plot view.
Yes, sir.
Are those from Gizmos?
Yes, those are from Gizmos. So what I failed to mention is at the beginning, when we imported Gizmos, I just imported all of them.
Oh, okay.
So I didn't have to keep importing the different objects. Yeah, okay. Those are Gizmos.
All right.
Okay.